Okay, the return papers, some of them I did mark on them by hand, but then all of them I graded with the GradeScope website. And we're still learning exactly how to use the GradeScope website to best benefit students. There's something on there to publish. I'm not sure if I have to click to publish or if they're automatically. I'll go through and click publish on all of them. You should have gotten an email about GradeScope, and you can go there and see the graded things there. But I also want you to just be able to use Moodle and not have to go there. So on Moodle, at least what we're trying to do may not have happened perfectly with all of the assignments you just got back. But you should be on the Moodle. If you click on the assignment, not in the grade book, but in the main thing in Moodle, it should bring up the assignment. There should be a feedback file. And that feedback file will have the grade markings and your original. So that's where you will see the grading. So the papers that you're getting back, I was going to and forgot to tell my office worker to make a mark on them to say that they were, processed. So you have some way of knowing this was actually processed on the paper, because what I do is I scan them and then I do everything electronically. Yeah.
I was wondering if you have any more of these potential.
I have tons of them, yes. Okay, so does everybody understand that about the returned work? Because obviously it's important that you can see what you got marked wrong on, so you can not repeat mistakes, or especially if it's like a format thing.
Oh, that's what you mean, box numbers in it.
Yeah, but that's meaningless. What's important is that's your box number, so you can always check. Okay, also, we have a tutor arranged, Brady Darrow. Here's his contact information. So he said he prefers email, but you can text him as well to get help, with the class outside of lecture. Remember also, my office, I have office hours. If I happen to be in my office and it's not office hours, still come on in, because obviously I live to help students. Homework. Anybody have questions about homework? I did not put the homework assignment here, unfortunately. Anyone have questions about homework?
Yes.
Yes, okay. I had my head down and I heard Ivy. So Ivy gets the floor.
Number 4.
Okay, give me a second to log into Moodle. Okay, so number 4, Sophia pushes with a 40 Newton horizontal force on a 4 kilogram box resting on a lab bench. The box slides against a horizontal friction of 24 newtons. Show that the box accelerates at 4 meters per second squared. A lot of 4s in that problem. Okay, so your question was how to do it?
Yeah.
Okay, so I am going to copy the question here. And paste it to the beginning of the lecture. Maybe. We'll see where it pastes. Yeah. And we'll look at it. So Sophia pushes with the box. The first thing that you should always do in solving a problem that has forces on it is to draw the figure, draw a diagram. So I draw my diagram. There's the box. And then I need to show all of the forces that are acting on it. Remember that 3-by diagram. All the forces act on the object I'm interested in. So I have to identify here, what object am I interested in? Sadly, I already told you, but what object am I interested in? The box. How do I know it's the box if I didn't already tell you?
Show the box.
Yeah. It says show the box accelerates. That's a good clue that the box is probably what I'm looking at. So all the forces acting on the box. Now, what direction is it going to accelerate? Okay, it's going to be, well, actually, it's going to be in the direction she's pushing. What I was looking for is, if we define horizontal as X and vertical as Y, it's going to accelerate in the X or horizontal direction. So all I really care about is the horizontal forces because those are the only ones affecting the direction it's going to accelerate. So I have the force of Sophia on the box. I have the force of friction on the box. The other two forces that I don't care about are the force of gravity, which is mg, and the force normal, which if I applied Newton's second law in the vertical direction, would tell me I could calculate it. And so we just look in the horizontal direction, apply Newton's second law. So why do I know apply Newton's second law? You could say it's because I've been doing these problems for longer than you've been alive. But at some point I had to learn, well, why am I going to use Newton's second law? Does anybody have a good, quick answer? Leslie?
Because you're trying to take into consideration some of forces and you're also looking for the acceleration. So then you can just manipulate the equation and you can find it.
Okay. Newton's second law is the law that relates acceleration to the forces. So they gave me forces and asked about acceleration. That's a really strong indicator that I need to use Newton's second law that is the connection between those. So I apply Newton's second law, which is sum of the forces, and I'm going to do it in the horizontal direction, is equal to mass times acceleration in the horizontal direction, which is the only acceleration. So then I just look at my picture. Sum of the forces in the horizontal direction, I drew x going to the right. So force pointing to the right is positive in the x direction. So the force that Sophia is pushing is positive. The force of friction is opposing Sophia's push, so it's in the negative x direction. Now, there are two things that remain, and a lot of you probably would have started differently. That is, the equation I just wrote, you would have written differently. What would you have, I heard somebody say, What would you have written differently?
Acceleration of net force over mass.
Okay. I'm just going to divide by m and I'll have that. Okay. So there we have what you had. A lot of people also like to put numbers in. I'm going to put in the numbers now. It would not have been a problem if I had put in the numbers earlier, but keeping it with symbols, to my brain, the symbols have more meaning than the numbers. If it says FS, it's whatever the force Sophia is putting on the box. And so if she puts on more, well, it's still going to be the force of Sophia on the box. Whereas if I put a number and she puts more force, well, I have to go back and redo everything. So to me, the symbols actually carry more meaning. But to a lot of students in your seats, the numbers carry more meaning. It doesn't matter when you put them in as long as you don't get confused. I am less likely to get confused by putting the symbols and waiting to the end. But now I am to the end, so I have to put in my values. So the force of Sophia was 40 newtons, and the force of friction is 24 newtons. So I have 40 newtons minus 24 newtons. That's replacing force Sophia and force friction. Yes, ma'am?
So if it's talking about acceleration, then why are the units in the question meters per second?
Yeah.
Squared.
Okay, so I edited the question incorrectly. Thank you.
Yeah, 'cause I was thinking, I was like, oh no, these
Yeah.
start matching up.
Yes, because units are important. She's learned.
Wait, there's another one that's like that.
Is there another one? Yeah, I edited all the questions. I copy and paste, and then things like units don't come through right, and I have to edit them. And apparently,
Yeah. I don't remember which one it was.
yeah, I will look through it. I know the homework is due today, so we won't have much time from when I get done with all my classes and stuff until it's due. But I will look through it again to see if I can find other errors.
Oh, wait, no, that-
Okay, but continuing with this, the final thing I need is the mass. The mass was identified as 4.0 kilograms. It doesn't say with a mass of 4.0 kilograms. It just says 4.0 kilograms. How do I know that's the mass? Because it has the right units for mass. If it's 4.0 kilograms, kilograms is a unit of mass. That means it has that mass. right? So we have to be able to read and identify from the units, which is why having an error like this can be debilitating because it would mean something different. So over 4.0 kilograms. And so now we just do our math. 40 minus 24 is 16. 16 divided by 4 is 4.
So what is the unit?
And so what are the units? Remember, a Newton is a kilogram times meter per second squared divided by kilograms. And so the kilograms here cancel, and I'm left with 4.0 meters per second squared. I very much apologize for having that 2 missing because, yeah, it's going to lead to confusion if you're thinking the problem through.